The issue that I was trying to solve was that movement science was not getting accurate data from their female athletes because the biometric sports vest that they had was built for male athletes. The vests for the female athletes had to go over their sports bras, and so there wasn't that skin-on-skin contact that the sensors needed in order to get that data. What Joshua Bailey wanted me to create was he wanted me to create a sports bra that also had biometric sensors integrated into the design.
I apply Newtonian mechanics to the human body, so I look at it from a sport performance perspective. So we're trying to optimize performance while mitigating injury. In the world of sport performance, there's some accelerometers or inertia sensors that track workload. And there's a sports bra that is used for it, but it's not a real sports bra. And so what we were trying to figure out is, instead of having these young women wear the catapult bra and a sports bra, how could we create one that could be universal across different bra sizes and comfort levels?
I went and interviewed some of the volleyball athletes, and from the athletes we were able to take measurements, and we also put them in the biometric sports vest that they were currently using to look at fit adjustments that were currently an issue with them, and we moved forward with that, with designing the actual first prototype of the bra. We started to make the straps adjustable after we talked with the model. We decided to go with a front pull system where you could adjust the sides by pulling the front and then it contracting in the back. We contacted a company called Butler Technologies who does biometric data collection. They have this very interesting method of being able to put on sensors without having to sew them in. So you could easily iron on the sensors to where you needed to for the bra, and they would stick and stay on there. When we were getting done with my side of the project, I realized that I was going to need more help with the technical side.
And that's what Claire's done really well. She's reached out across campus and identified the people that have the skill set that she needs.
So my part in this project was to handle the electronic side, which includes the design, the interfacing, and the signal processing components, as well as getting the data onto a computer for later processing. What I originally thought was going to be a trivial task was anything but. I believe I read close to 30 to 60 research papers, application notes, and lecture slides to get something that should work. The board came online properly, the LEDs flashed up, but the signal left much to be desired. I had the thought that, based on every bit of research, that 60 hertz noise would not be an issue. It absolutely was, and it drowned out everything that was necessary to look at. So that's been the ongoing struggle, is figuring out how to get rid of that. General benefit of this sort of project is that you tend to see the decouple between theory and reality, usually when you slam face first into it.
I got into this project mainly because Lori, my mentor, brought it up to me in a meeting when I was discussing about doing an undergrad research project. And she's like, I have something here that is working with another department, but it is basically taking technology and fashion and merging it together. And I'm like, I'm in.
I always look to bring students into projects because it opens their mind, but it also provides them a little confidence in where they can go with their future.
Collaborating on this with multiple departments was a huge goal for me because I really wanted to see what we could come up with so many different minds working together.